Hello, guys, and welcome to TechMasterminds. My name is Kate.
And my name is Oksana.
We are truly happy to see you on our second event that is held by Sigma Software. And today I want you to ask you to make yourself as comfortable as possible, forget about all the worries of the day, and let us transform you to the truly engineering meetup.
TechMasterminds are webinars with people from top tech companies. They spread their knowledge, and that's how we gain our tech community. These webinars are monthly, so subscribe our YouTube channel and don't miss our next topics.
Yes, and as I already said, this webinar is organized by Sigma Software, a consulting company. And when I say global, I mean truly global, as we have offices all over the globe, as our entities are, as we have people from Bulgaria, from Poland, from Ukraine, from Brazil, Germany, Czech Republic. So thank you guys for your interest in coming to our meetup.
Just a few words about our agenda. So we have a tech talk for 40 minutes. After that, we have Q&A session in Zoom. So we will move from our YouTube. We'll give you instruction later.
But you can also ask question in the chat, YouTube chat that you see right now. And also we will transform all the questions to the live session. So you can ask our speaker questions, share your opinions, and just have a live discussion in this virtual meetup. So, and I'm ready to invite our really good friend, senior software engineer from Google, executive director of WebbyLab, Viktor Turskyi. Are you with us?
Yes, hello.
Hello. Really nice setup, really nice studio. Viktor, I give this virtual stage to you. And in 40 minutes, I wish you a pleasant audience, no worries, and enjoy the speech.
Okay.
See you.
Start. I will share my slides. Okay, so a rather special topic today, and it's rather because I will not talk about modern approaches, but things that worked in 7, and so in case it's like fundamental and maybe useful for someone not useful. And this talk is expected to be interactive, but in online format it will not work this way. So I ask everyone to prepare a question and ask in YouTube or in Zoom after the talk. So several words about my experience before going to technical things. I've worked in IT for more than 20 years. And during this time, I worked at Google, and before that, I worked at WebbyLab as CTO and CEO for 12 years. I'm one of the co-founders of the company, but today's talk is related to events happened even before WebbyLab. So, but in general, yeah, we'll see how it goes. And I have some contribution and relation to Ukrainian community of developers, especially the JavaScript developers. I'm author of JavaScript Telegram channel, and I have YouTube channel. You can search for it, like Viktor Turskyi про програмування. It is in Ukrainian, and I have some open source project. Okay, and let's start with what I'm going to talk about, like with. So I would like to provide you some details about that project that I worked in 2007. It was a service similar to Gmail. It was a web application, single-page application, mail service, SMTPs, IMAPs, POP3 service, and a lot of such stuff. But I will not talk about all of that today, but just about small piece of the whole project, and even not about web architecture itself, but about the way how we deployed such projects that time. Okay, so, and usually when you start a new project and want to deploy it to internet, you create a server. Today, you can create a virtual machine, but that time you had to buy real hardware and put it into data center. You see here like racks with servers, and you can see small servers, 1 unit tall, large servers, 4 unit tall. And you buy such server or similar one, move it to data center, set up everything. Usually you have one server with web application, database, web server, file system, all of that in one computer. And usually it works for small project, but will not work for larger applications. And when you need some sort of reliability, you want to have fault-tolerant application, and so on. And the first question, let's start with scaling, but today we will discuss scaling and fault tolerance. Let's start with scaling. So how to scale such applications? The easiest way is to do vertical scaling, when you just buy more powerful server, add more memory to it, add new larger hard drives, better CPU, and so on. But you need a system that is able to utilize and use all of that resources. And that time, Apache was very popular. Today, it's not so often used, but that time it was very popular, and there were several ways how you can launch your application. And our application was written in Perl, and there were several options. First option is CGI, Common Gateway Interface. When you, for each request coming to your server, you launch your application, it processes request, and then exits. It works, but not very good, because it requires a lot of resources. You need to start each time the whole application. And because of that, usually you have a lot of small application for each page. You have small Perl script, and it's hard to support, requires more resources. So it's better to avoid such approach and to use a different one. But I know people, companies, which uses CGI even today on, for example, on routers, when you do not need to process a lot of requests and you do not want to have running process all the time. So another approach is to, that time it was like mod Perl was very popular. It's a module for Apache which allowed to run, to have interpreter, Perl interpreter inside of Apache process, and you do not need to run this interpreter each time on each request, and it was much better than CGI. Another alternative is just to use pure Perl HTTP server. It's very similar to what we have today. For example, with Node.js, we have built-in HTTP web server and can run Node.js application without any Apaches, Nginx, and so on. So it works, but you cannot handle of traffic, because you need to handle static content like images, CSS files, and so on. And with Node.js, you can do it because it's asynchronous, but with Perl, it's synchronous. It's harder. For each request, you will need to have a separate process. So it's not very scalable. And because of that, people usually use reverse proxy, for example, Nginx or another one. And it's like a standard setup today, but I don't know why, but fastCGI is not very popular today. And that time there was another option very popular to use fastCGI plus Nginx. fastCGI is something similar to HTTP 2.0 when you have persistent connection to your application, it processes requests. You do not need to run each time a new process. And we decided to use this approach. Moreover, what is interesting that time, now Nginx is like almost 20 years old technology, but that time it was only 3 years old technology. It was absolutely new. Comparing, for example, to React.js, so we know that React.js is a rather modern thing. but React.js exists already for 10 years, open sourced for 10 years. And that time engines existed only for 3 years. So it was very, very new, and no Docker was that time, no. So a lot of tools that we use every day were not available. Okay, so it's clear what we can do with vertical scaling, but what if we want to add more servers? Can we do it? Yes, sure, we can use, it's named horizontal scaling when you add more and more servers, and we can add 1, 2, 3, 5, 10 servers. And on this slide, you can see that I've added 2 more servers, and the question whether it will work. And in such setup, it cannot work because you need to have a load balancer, and a load balancer will distribute load between all of the servers. So you need to set up a load balancer, and we did that, and it was a responsibility of software engineers or system administrators to do it. In our case, it was responsibility of software engineers. And we had load balancer, which was in real the same Nginx service, which was responsible for distributing requests among all of the application servers. But the main problem, as you see now on this slide, that we have database or like some storage in each application server. And it means that our servers are not disposable. And according to 12-factor rules, to 12-factor app rules, it is a good practice to make your application servers disposable. So you should be able to add new servers or remove existing ones. So anytime you can just stop one of the servers. For example, you have auto scaling, you add new servers and remove when you do not need them. And you cannot do this if you have some persistent state on your server. So what we did, we decided, okay, we need to move our storage somewhere outside of servers and make our servers stateless. So now we have stateless application servers and a scalable storage. We will return to the storage and how we scale it later, but let's focus on application servers. We decided, okay, if we do not have any state in application service and any persistent state, it means that maybe we do not need any hard drives at all. So we decided to remove hard drives from servers at all. And but still there is a question how to add more servers, how to set up everything without hard drives or with hard drives. You need to have operation system, you need to set up network, you need your application code, and so on. And usual approach for many people, for many teams, was to just copy your code using SSH and run all of that. But we decided to invented something similar to Docker before Docker existed. So the idea was to have images that we can deploy and run and roll back to previous image and so on. So we implemented provisioning via network boot. There is such thing as pre-boot execution environment, PXE, and it allows your server to load via network. And how it works in general. In general, you have a network card. It should support PXE protocol. And network card does a request, broadcast request into your network, asking for network configuration, asking DHCP server for network configuration. And DHCP server, you usually have DHCP server on your home router. So it is responsible for providing information about IP addresses, DNS servers, default gateways, and so on. And it works here very similar to the way when you connect your mobile phone to your home router, except that it uses additionally PXE extension, and it means that it provides extra information about TFTP server, which has image like bootloader, small application that should be loaded into your server, and which can then continue this like boot process. So at first we load this small bootloader from TFTP. TFTP is like trivial FTP. It's the same protocol as FTP, but simplified. It does not support authentication and other stuff, but in general, it's enough to do network boot. So what happens here? So at first we load this bootloader, then load kernel, load the whole image using NFS. I will show it on the second slide. So we load kernel, init network, mount TMPFS. So our servers, give me a second. So we have such servers, and they had 4 gigabytes of RAM, and we decided to split this RAM in 2 parts, 2 gigabytes for memory itself and 2 gigabytes for file system. So we had like 2 gigabytes of file system. And what we did during network boot, we load our image, we unpack image into this TMPFS partition, and detach from NFS after that. So from scalability perspective, it works like that. You insert a new server into a rack in data center, press power on, and it will load all of the stuff, latest image from PXE server. And if you need to roll back, for example, to a previous version of your application, you just update your server which contains images and reset all of the application servers. And after reboot, they will have a previous version of image. So it's very similar to what we do with Docker today, but with real hardware. And it follows almost everything from 12 factors app, but even before it existed. So 12-factor app rules from Heroku appeared 4 years after we did all we did. Okay, so now what we have? Now we have load balancer. Now we have stateless application servers. We have PXE server, like boot server. We have scalable storage. And everything looks good, but in our application servers, we have logs. System logs, application logs, analytical logs, events, and so on. And we cannot store the logs in hard drives because we do not have hard drives. And we do not have some modern cool tools which will allow us to store logs remotely somewhere. What we did, we decided to use such tool as syslog-ng. So in every Linux, you have syslog service, and you can replace it with any other implementation. And we decided to use syslog-ng. And syslog-ng allows you to have different rules for log events. And you can, for example, resend events from your server to a different server, which aggregates all of the data. So we added to our setup syslog server, which was responsible for aggregation, processing of logs, and so on. And it was using scalable storage for storing everything. So this problem was solved. Syslog-ng is a great tool, and I believe it in like active, not active, but in a development, and can be used for such purposes. Okay, and let's think. So we have now scalable system, and it partially fault tolerant. So we can remove application servers, but what will happen if our load balancer fails? We need failover for our load balancer servers, and one of the solutions is to use DNS round robin plus failover. How it works? You can have several load balancers, and each load balancer has own IP address, available outside public IP address, and you can add to the same domain a record with two different IP addresses, and DNS will return both IP addresses on each request in a different order, but in general will return all of the IP addresses of all load balancers. And such thing is supported by protocol, so clients will take one IP address and will connect to one load balancer or to another one. But if load balancer fails, we need to remove one IP address from DNS server. And we can do it. We need to have some sort of monitoring tool which will monitor our load balancers and will update dynamically DNS records, but we can have issues with caching because DNS records are usually cached by like everywhere. They're cached on, can be cached on your internet service provider side. It can be cached in your router, home router, in operating system. It can be cached in browser and so on. And you can set up TTL, like time to live for your cache, for your DNS records, but it works, but not always. So there are other solutions for that. Several of them are like most common one is VRRP, Virtual Router Redundancy Protocol, and another one is Common Address Redundancy Protocol. For example, CRP can be used for not only for routers, but for hosts as well. And how it works. In general, you can have two load balancers, for example, and they share the same virtual IP address. And when request comes into your network, and when ARP protocol is used to resolve IP address, or like not IP address, MAC address from IP address, then only one of both load balancer will answer. And at the same time, both load balancer have real IP address. So monitoring tool can check whether they are alive, and when one of load balancers is not alive, then another one will reply to like with virtual IP address. So it's possible, and that time we decided to use CRP. Okay, so we solved this issue, but it can be solved with DNS round robin as well. Okay, so let's discuss storage. It's a photo of servers that we were using such servers that time. They were rather expensive, and you can see that it supports 16 hard disk drives with hot swap. But the time, as I remember, we had like 1 terabyte hard drive, so the whole server was able to store 16 terabytes of data. And but you work with like real hardware with real hard disk drives, and when you have a lot of hard disk drives, they will constantly fail. So at least every 6 months, one HDD failed. So what to do if it fails? We need to have some sort of disk redundancy, and there are technologies like write 6, write 5, write Z, write. So you can have write. It means that you will have one redundant disk for write 5, and data will be distributed across all of the disk in a way that if you will remove one disk, everything, the whole data will be available. So you will lose a little bit of space, but it's not a problem. For RAID 6, it's the same, but you can disconnect 2 hard disk drives. They can fail and everything will work until you disconnect the third one. But that time we decided to use ZFS. ZFS is like very cool file system, and that time it was the only file system that supported all of the features that we wanted. And the only issue was that it was supported only by Open Solaris. Linux, I'm not sure whether it supported currently ZFS is supported in Linux, but that time there was an issue with licenses, and I believe today we still have them, and maybe ZFS is implemented via Fuse, file system user space, so in user space instead of kernel space. But in general, that time it was possible to use ZFS only with Open Solaris, so we had to manage to set up Open Solaris and to work with that as well as software engineers. Okay, but yeah, with right you can solve HTTP failure, but what will happen if the whole server fails? And you need something similar, but on network level. And we decided to use such technology as distributed replicated block device. So it's a virtual block device which appears in your Linux system, and you work with it as usual. You can create any file system on it, but in real, it mirrors all of the data to another server. And if you power off one server, everything will work. So you have like 2 copies of data. And we decided to use, and it's rather good technology, I can say, but we spent some time to set up it. Okay, the next problem. So we now have fault-tolerant storage, but we need to solve scalability issues for our storage. It's easy for files, because files is similar to distributed hash table. When you add the new servers and just distribute everything, it's not a problem. And the same for memcached. We used memcached for caching, and it supports, so it's distributed hash table. You can use consistent hashing on client side, and it just works. But for main database, in our case, we had several different databases. We migrate from one to another. So I will not name exact database here, but in general, the concept was to shard data by user ID, and it worked perfectly because each user have own inbox, if you're talking about emails. And we did some sort of data rebalancing. So we had meta server, which was responsible for knowing at which server we have the data. And when we add a new server, we did some rebalancing. And for that, we had to introduce log server, a lot of small pieces. In general, it's not always a server. It can be a service. But in general, the idea was to use sharding, and for memcached, it was a consistent caching, and for file system, it was NFS, network file system, and it worked very similar, similar to distributed hash tables. So it just worked with sharding. So sharding for everything. And another thing, I've promised you that I will not go deep into I will not talk about mail specific stuff, but I would like to mention one interesting thing. So we decided to write own file system as well. And the idea is the following, that when you store emails on file system, you usually use mail dir format, and different services like IMAP, POP3, SMTP supports mail dir format, but it was not usable for web application because you need to have quick access. You do not have time to parse all of the mails and so on. So we created a virtual file system using Fuse. Fuse is allows you to write a program which will intercept system calls. And for example, when SMTP servers or IMAP server tries to read an email, we intercept this system call and go to database and return information from database or from our distributed storage, which is so our file system will go to meta server, ask to which server it should go to get corresponding email, will go to that server and will return this information via Fuse to IMAP service. Yeah, it's hard to explain online. Usually it's without interactivity, and because of that, I do not like online talks. But yeah, if you have any questions, please prepare them. And in this, so what we have now? Now we have several load balancers, one main and one for failover, several memcached servers, boot server, syslog server, our application servers, and I guess that's it. And a lot of different services like log servers and so on. And for monitoring, you can use now a lot of different tools for monitoring, but that time Nagios was very popular and Munin. And Munin, as for me, is a great example of how you can create very simple and at the same time very powerful monitoring system. It was very easy to write Oven plugins, so we created a lot of plugins, but Munin has hundreds built-in plugins. So it's, as for me, it was a great thing. And we were using Munin on other project at WebbyLab for a lot of years and maybe still using. So, and it looks, we solved a lot of problems, but in real, there are a lot of other problems, not related to scalability, but for example, related to OS, to security. We need to set up firewalls, OS permissions. We need to update and manage HTTPS certificates. And it was before Let's Encrypt and so on. And we need to manage our hardware, to monitor load, network management, system software management, updates for system and so on. So that time it required, you see, it required a lot of effort to just launch an application. And after that, first clouds appear, and first clouds were great. So they solved a lot of things, like not a lot, some of the problems, but at least they solved hardware management problems. So you can create virtual machine. You do not need to think about write arrays, because now you expect that you do not expect that your hard drive will fail. Yes, file system can fail, but under the hood there is more than one hard drive responsible for your data, so it's good. Storage management, partially first cloud supported scaling, so at least you can add quick, much faster new servers than buying hardware and putting it into data centers. Okay, and that time also Google App Engine appeared, and it was really cool thing. And I like the approach of Google App Engine, but it has a lot of issues as for me. And the main issue was that it required your application to be written in a specific way. So you cannot just deploy your application. You need to write your application for Google App Engine. And it supported limited number of types of workloads, but it appeared in 2008. So we have it for many years already. But as for me, it was not very like usable. Even if I work at Google, I say this. Okay, but what everything that I say today, so it's of Google, and everything of this is my personal experience. So yeah, let's continue. And then containers infrastructure appeared. Different things like Kubernetes, Elastic Container Service, hosted Kubernetes, and so on. And it allowed you to work with containers, but in real, you still have a lot of things to solve. Then serverless 1.0 appeared, like AWS Lambdas, Google Functions, and so on, but there were no Docker support, no concurrency. Conceptually, they were similar to CGI when you have like small functions, and they will be called to process small events. It was not expected that you will run large you will run large Java application with your Lambda Google Cloud function. And like limited support for different workload types as well. So as for me, it was very promising, but at the end it was somehow disappointing because so it can do much more. So it is useful, but can do much more. And what I like that now cloud providers move in a direction of serverless to next generation serverless approach. As for me, it's still in progress, but I see a lot of movement in that direction. And I've joined Google and work at Google Cloud at Cloud Run team because I like this approach, and it's like, as for me, very, very very interesting approach. And we have some of providers already, or like services which implement this approach. Google Cloud Run, it's like platform as a service, but serverless 1 and serverless 2, they both platform as a service, but provide different capabilities and different benefits. So we have Google Cloud Run, Heroku, Fly.io, AWS App Runner, and others. Okay, so what I would like to do now to show how all of these problems that I've just discussed in all of the slides can be solved today by software engineer. So let's start with a simple application. We have simple application. I've created it on GitHub. It has a Docker file with two-stage build. It's written in Node.js, and I want to deploy and have like scalability, fault tolerance, disposability, logs, metrics, everything. So what I do? So first of all, I click Create Service here in Cloud Run in GCP. So and click Setup with Cloud Build. Select my repository. Here's it. Next, say that I have Docker file. Save. Allow unauthenticated invocations. Press Create. Okay. Let's name it in a different way. Press Create, and that's it. So after this, it's all of the things that I've just described, all of that are solved. And what we have here, I've already created, before the talk, I've created similar service, not to wait until it will be deployed. So we have here metrics, we have here SLOs, like alerts, we have logs, moreover, we have continuous deployment. So I can open, for example, our application, and if I will go to GitHub, click here, edit, for example, title, Sigma software, commit changes, it will be automatically redeployed. So let's check. Yeah, we see that it says that building and deploying from repository. So now we will have a new version of application deployed. Moreover, we can manage our traffic. We can, for example, redirect or like have something similar to canary deployment when we say that our new revision is available only to 10% of traffic, or we can have URLs for both version, for previous one, for new one, for different revisions. Like, let's name it version 1. And we have another one. So version 1. Okay, it's version 1. And here we will have a different version. When we will click, we will see a different title after deployment. Also, we can add custom domain. For example, I've already added sigmasoftware.web.app, and it can be done in one click. Like we click Firebase hosting, add custom domain, and we do not need to manage like security, HTTPS certificates, and so on. And as for me, it's what I was expected to have from Google App Engine, but it only now appears. I do not know why it took so much time. And it's a project that I worked on, and I've decided to move all of my personal project to Google Cloud Run as well. So if you will have any questions related to Cloud Run, feel free to ping me in Twitter. And I guess that's it for today. So if you speak Ukrainian, find my YouTube, join my Telegram channel, JavaScript. Yeah. That's it.
Thank you,
Do we have any questions?
I'm not sure if we have it in chat, but we will have this after party, and so people will ask you question. Yeah.
I almost do not hear you.
Hear me? You hear me now?
Oh, yes, much better.
Okay, cool. So I told that our guests will have an option to ask your question in loud in our Zoom after party. So guys, please join the link soon. And before we will join the session, I want to thank you to our speaker, Viktor. It was an amazing speech. Thank you so much for sharing your knowledge.
I want to thank you. And this is not our first event with Viktor. I remember many years ago, we had events offline and then during the COVID. And this is our like first or sixth events together. And I hope this is not the last one. Thank you.
Yeah, thank you for inviting me.
Yeah, and regarding question, guys, right now in the YouTube chat, you will see the link. So please join and ask Vita any question if you have any. And we also got the announcement in our third event that will happen in the end of July with Paul Chubati, speaker from LinkedIn, who will tell us about how to become a better engineer and by changing your engineering mindset. So please secure your spot and don't forget to register as number of seats are limited. And we hope to see you in 30 seconds, in Zoom.
Thank you.
Thank you.